So here now, if you do make this on def config, so it configures it so that you can be able to compile it. You can be able to build it for Intel Edison, and then you can if you need to improve on you need to add extra packages. You write make menu config. So menu config, it will bring for you this wonderful. You see, can you look? You see, can you see that?
Yeah.
Yeah, it's this very beautiful blue and white, and then you can move with your back and like up and up, forward, back, forward. No, key the up and down keys. So if you want to, like you see the device drivers, if you want to add a driver, if you have a new device and you want to add a driver, you come there. So let's say you want to, you can be able to add and remove a driver which you need to, like if you want to have GPIO support, you press Y. Okay. Y for yes, and then no, N for no. Y for adding it, and then no is for removing it. Okay. And then you exit. You can if you look at it, it will tell you the processor features, things like that, and then the final thing that you do is what you say make. The final thing that you do is let me just type it. It's called make, and then you put -J4. Okay, this is the final thing that you do to build the Linux kernel. So you are making it, and it's using a make file, and then -J4. 4 there stands for the number of processors that you have. So, yes. So the number of processors that you have, usually -1. Okay. So if you have a quad core, like I have got an i7 over here, so I can do J6, whereby that is 6 it's an i7, so I'm using like 6 processors, something like that. And then this will I want you to see what it's doing. It's downloading. It's going to download the sources which are not there already. I already did this at work, so it's going to be it should run very fast because I'm on an i7. Usually in companies or where people are very big companies, if you want this to go very fast, you are using like a server, some server which is very fast, and the internet is very fast, and then it builds for you.
Okay.
Yes. So as that is going on, let me just show you on the screen. So the output, or whatever you are going to come out with, yes, it's going to, whatever you are going to come out with is going to appear in the directory output. Are we together?
Yeah, I am here.
Yes. So whatever you're going to have is going to be the output, or whatever file that we are going to make is going to be in the x86 boot, and then it's going to be a busy image, a Z image.
Okay.
Yeah, it's a Z image. It's okay. It's a special image that the Edison will get, or which it will load. Yeah, and then for the root file system, you have something called rootfs.cpio.bz2. So these are just archiving formats. You know, like I know you are aware of zip or tar.gz, tar.gz. You are aware of .bin. So those are just formatting, the formats for zipping whatever you need. Yeah, just file formats. So basically, the two file formats that you are going to need is the root file system. This is the name of the root file system, and then it is cpio.bz. That is And then there's another one which is called BZ image. BZ.
Okay.
Yeah. Yeah. So this takes a while. Sometimes it takes even 7 hours. If your internet, it depends with the internet, how your internet is, and also how fast your laptop or your computer is. Yes.
Okay.
Yeah. So the
But
next,
you had done.
yeah, I had done it. So it's going to go very fast.
Okay.
Yeah. So let's go to the next part. I have opened Nini. I have opened another one. So we have got what is called build root. So
Okay.
yeah.
Yeah.
So the build root, as I told you, build root is used for building the root file system. Yes, build root can also be used to make a tool chain. It can also be used to make a root file system, a Linux kernel, and also the root file system, and then the Linux the kernel, the bootloader. So the same way we had make edit on config. Okay. So we also do make edit.
Could you ls inside the file?
Yeah.
Could you do an ls first?
Okay. Yeah, I'm showing you that. ls. Okay. So this one is slightly different. Yes, it's the directories are a bit similar to, because they are trying to apply to some Linux standards. So inside it also has the architecture directory. Okay.
Yeah.
Yeah, but then the architecture directory has got just make files for various architectures. It doesn't have source files. Okay.
Okay.
Yeah, because the source files are going to be downloaded from another source. Okay. And then it also has got the board. So look at the board directory. So if you look at the board, which board do you see there which you know?
Raspberry Pi.
Yeah.
I can see ARM.
I
can see
BeagleBone.
What?
BeagleBone Black.
Oh yeah.
There is Asus or Asus.
Asus, Amadeus. Yeah, I see. Okay.
Yes. So as there is for Intel, there is QEMU, there is, okay. So those ones are boards. Sawa.
Okay. So why do we have to differentiate them if what we are building is a file system?
Yes, so you're going to differentiate them because these boards, they have different features and functionalities which are varying from one board to another.
Though I thought the file system has a specific standard, like specific what's this, like format.
Oh no, they are different. First of all, they take different file formats.
Okay.
And then they have different memory footprints.
Okay.
Yeah, so one can be having, I don't know how many GB, the other like how many MB of RAM, another one.
Okay. Okay.
Yeah, so that's why they are different.
Yeah,
I
understand.
So there is this folder called DL. This is a very important folder. So DL is where you are going to download your stuff and put them there.
Okay.
Yeah, like if you are building libraries, I told you that you need tools. Let me just start by saying tools. For you to compile things, for you to compile C code, so you need the GNU C compiler or GCC.
Yeah.
You also need things like there is FFmpeg. Okay, there are others which are packages. So which means if you download stuff, they are going to be stored under the DL. DL is standing for download folder.
Oh, okay.
Yes. Yeah, everything that you download will be stored there. And then there is toolchain. Unaona toolchain. What did I say?
Yeah.
What did I say toolchain is?
A tool chain. Tool chain, it contains what's this?
Basically, as it names that, tools for compiling the sources.
Okay.
Which are GCC,
G++.
G++, there is GAS.
Yeah.
So wacha tu nione hapo ndio uone. Najua. Okay, toolchain GNU C compiler, GNU assembler, GNU C compiler, and a lot of, then there's also what are called libraries, C libraries that are also there. So
Okay.
naona yangu imecompile.
Yeah.
Inaitwa hapo BZ.
image.
Yes, so it's under, iko hapa under architecture, x86, boot, image. Sawa. Yeah, so
Okay.
so this is what I will boot, or this is what I'm supposed to copy the Intel Edison, and it will run. So it is the kernel. Sawa. BZ image is the kernel format. I don't want you to confuse stuff, but I told you that the kernel is the most important, is the second most important part, and the format that you are going to use for Intel systems is BZ image. Are we together?
Okay.
Yes. Okay. So build root hapo tumeona hiyo docs are just documentation. It has fewer things. So
yeah.
Yes, and then to do it again, to work with it, if you use the same way, they have standardized stuff, so it makes it very easy. Intel def config, you do the same way. I'd already done this also, as I told you. So, and then you can also do make menu config. And then the same format. You see, this one has few options.
Yeah.
Yes, and then you can change the target. Okay, let me show you. You see hapo targets.
Yeah.
What are these?
Architectures.
Yes. So these ones are various architectures. So if you for example, if you wanted to do something for Raspberry Pi, you'd change it to ARM. ARM there. There is big Indian, little Indian. You should know what those are, or I'll tell you with the time. Then the binary format.
Okay.
The binary format it is using ELF, and then the architecture variant. Intel has got other various variants. Then the build options. So this is the you remember the def config we were using, the Edison def config.
Yeah.
That is where you specialize it, or it is stored in this directory. It's under Bob's printer, Home's printer, dev, Edison, build root, configs. It's automatic. Apple, you don't need to change anything. And then the tool chain, the C library. I told you the tool chain is the whatever you need to use. The C library is there. Then the GNU, it's using the build root tool chain.
Okay.
Which means it's the tool chain that comes pre-installed with the build root, or you can use an external one. And when you are using an external one, you'll put the path you may install.
Okay.
Yes, you've installed it under C or whatever, or under /dev, whichever directory where you have put it. So you put your go path. That is where, yeah, that is where we put our go path. Yes.
Okay.
Yes, and then the Linux kernel. For here, you remember we had already built the kernel.
Yeah.
Yeah, so that is why this play here hapa we are not selecting kernel, yeah. But select, itakwambia the kernel version, which is the latest.
5.
Yes, which is 5. 5 is the latest. So 5 is the latest. You can have a custom version. You can custom git, like like if you clone some GitHub repo ya mtu of some kernel, unaweza weka hapo kwa kernel kwa GitHub. You can put it there. Let me be official. You can use there. You can have a custom tarball, yeah, like it's in form of a tar. Yes, you can put it there. And then yeah, you just tweak things and make changes to the kernel, how it looks like. But then the format, you see the various formats that are there, the BZ image, and then VM Linux. So those ones are kernel formats. There are various in ARM, in PC, and in Intel. They are different, but Intel uses BZ image or BZ image. So, but now atuitumi hapo, and I told you use Y to activate and no or N to deactivate. So,
okay.
Then I want you to look at target packages. Target packages are now, if you are installing things. For example, if you come to network applications hapo, have you heard of DHCP? You know DHCP, Cindy?
Yeah.
For networking. There is also Dropbear for networking, FPing. There is NetPlug, you know, Mosquito. You've heard of Mosquito? Yeah, MJPEG streamer is for streaming JPEG video and images. OpenVPN, do you know what OpenVPN is? The OpenVPN client. So these ones are networking packages. Hapa ndio sasa umekubaliwa kusema packages. Sawa? Yes. So
okay.
So you see, these are the packages that are going to be installed in your root file system. Yes. So TCP dump, you know TCP dump? Wireless tools for doing some networking. I know you are somebody who likes scripting languages. Munakuja hapo kwa scripting languages. So let's say we want to install Erlang. No. I'm a PAL. Sindio? This is where in others you'll see lower. Hapa ndio hata nini huwa inakuwa. Go itakuwa hapa, Python, the JavaScript, even JavaScript, Node.js zitakuwa hapa. So,
okay. Yeah.
Or if yours is missing, you can go and add.
You can add.
Yeah, so mimi nitazitoa since I'm not, I want this to also compile smoothly. Erlang, so sawa. Some of them have problems, some of them a mail client hapo ukitaka kutuma email real time, text editors, Vim or Emacs, audio and video applications. For example, for ALSA is for like sound, MPEG video. Hapa ndio utakuwa na things like video for Linux, FFmpeg for streaming video, all those kind of packages which are used for video and audio. System tools, Android tools, system tools like, for example, EFI. Let me tell you. Have you heard? Do you know what? Let me tell you one here, which I think you may know. Which one do you know there? EFI boot manager. It's for Docker. You know Docker, Sindio? Hello. Yeah. Docker CLI.
Yeah.
Command line interface. Okay, so these ones are extra tools. So when you have your tools, you'll be able. So all these packages, they're going to be put together in what is called a root file system. Yeah.
Okay.
And then when you boot the root file system, when you boot the OS, then it comes installed already. And then yes, the final thing you do the same way we did the other one is make -J like 6. I'm using 6 cores. Thank God my employer has given me a fast laptop. This will like go very fast. Sawa.
Yeah.
Yes. So yeah, it's downloading the sources. I'd already downloaded them, so it's just checking. And you see how fast that was.
Yeah.
So it has produced for me a root file system.cpio.bz. It's under this directory home ndio hiyo. Sawa.
Yeah.
Yeah, so now you can so basically what I have done is I have successfully compiled a root file system, which is rootfs cpio.bz, and a Linux kernel, which was the bz image. So yes, and yeah, and then this is how to load it onto the board and how to boot it. So hii tutafanya maybe kesho. Okay. The last thing that I need to show you, the last thing that I need to show you is that there is also, that is one, I don't know whether it's too much, but maybe we can do it tomorrow. So there is also another build tool which is called OpenWrt.
Okay, that one we can do tomorrow.
Yeah. So yeah, so yeah, that is.
But this one is
yeah.
This one is building a vanilla image.
Yes, this is vanilla, meaning from. Okay, we are not using, like, we are using very latest sources, and check out what vanilla means. Vanilla Linux, like very latest sources, and the tools are watu hawajaweka vitu mingi, something like Ubuntu, people have put their own stuff and they have customized, they have tweaked it, but with this one they are very like from the main tree, something like that. So check out what vanilla means. Okay. Yeah. So
thank you. Introduction. Yeah, you've heard me.
No.
I said thank you for the introduction.
Question you need to ask.
You're still recording?
No.
Yeah, you are.
Oh.